Hey guys, welcome back. So today we're taking a look at piecewise limits. These are limits based on a piecewise defined function. The idea here is you have to be careful with where you're substituting the piecewise function, where x is going to which part of that. This was pretty clear on the graphs. We talked about that in the couple of videos ago, where you saw you had your gaps. So on the left side was approaching one number, right side approaching a different number, so a lot of times they were not converging together. So that's like we're kind of like showing right here. So we're talking about the left side limit for -1 for part A, right side limit for -1 for part B, and then if they're the same, then what's the limit for C? Because C only exists if both left and right are the same value. Now the left side value is typically going to be, well, will not typically, it will always be the left, the less than value there, whereas the right side value is based off the greater than. So for part A, when we say our limit as x approaches -1 from the left of f of x, we're worrying about the x over 2, so -1 over 2, and that's it. For part B, doing our limit as x approaches -1 from the right of f of x. So that's going to now be the greater than portion of that. So that's going to be a -1 squared minus 2 times -1, which is 1 plus 2, which is 3. So again, part A, we have that limit equal to -1/2. Part B, the limit is equal to 3. So whenever they ask for left or right side limits, that's all you're really looking for. If they want it converging together, you have to do them both. And we see, oh, they're not the same number. Therefore, it does not exist. Because this would be the perfect example of a graph where they're at two different locations. All right. Now, if we have a larger one, again, it just kind of depends on what they're looking for here. So they want -2 from the left. -2 is the transition location, so it's going to be based off this quadratic, this 5x squared minus 4x plus 1. So we would say 5 times -2 squared minus 4 times -2 plus 1. We'd get 5 times 4 plus 8 plus 1. That whole thing comes out to be a 29. Just substitute to that. If they wanted -2 from both directions, there would be no plus or minus. We then have to consider what's happening on the left and the right-hand sides. Part B wants 1 from the right side. So 1 is, again, a transition location right here and there. But the right side wants the greater than. So we're going to substitute that into 9x minus 1. 9 times 1 minus 1 will give us 8. Now, we can still do our regular limits where we have other numbers besides the transition. Limit as x approaches 0. 0 would fit here in between -2 and 1. So that 0 is going to go into that function. So I'm going to say the square root of 3 times 0 plus 6, which is just the square root of 6. So just make sure if it's not a transition location, in this case the -2 and 1, you just find the appropriate inequality that number matches with. For example, part D wants it at -3. -3 is less than -2. This would go to the quadratic piece. 5 times -3 squared minus 4 times -3 plus 1. We would get 5 times 9 plus 12 plus 1. 45 plus 13. We get 58. Don't need to worry about left or right sides there, just simply because it's only one location. Now for E, though, E says limit as x approaches 1. 1 is transition, so we do need to consider left and right sides. We already know that the right side limit is 8. We did that on part B. So we need to figure out what is my left side limit for 1. Left side limit would be the square root portion there, so that's 3 times 1 minus plus 6. Square root of 3 plus 6, square root of 9, which is equal to 3. So left side of 1 is 3, right side from part B is 8. They're not the same number, so that would be a does not exist scenario. All right, so that's what we're doing with our piecewise limits. It's very straightforward. The biggest key is watching out for the scenarios where you have to substitute into both functions left and right to see if it converges. But that only has to occur when it does not have a plus or minus by itself, and it's at a point of transition. Parts C and D, we didn't do that because 0 and 3 were not points of transition. Also something to note, that part C had said 0 from the right. Part D had said like -3 from the left. It wouldn't change anything because there is no change in the graph on the left versus right side of 0 or -3 because they're not, again, points of transition. All right, so that's it for the piecewise functions. We got to talk about continuity and limits at infinity. So those are coming up next. I'll see everyone next time for those two videos.